Welcome to my presentation. In this presentation, we shall try to solve system of linear equations using matrices, and this time we are looking at an application problem which involves system of linear equations, and then we will solve that using matrices. Let us say that a fundraising event was held at your school for 2 consecutive days. On the first day, 100 adult tickets and 175 children's tickets were sold for a total of $1,225. On the second day, 200 adult tickets and 316 children tickets were sold for a total of $2,348. We want to know the price of the adult ticket and the children's tickets. So to solve these types of problems, we're going to use some steps, and then we're going to see how we can solve them. We're going to write the information down in system of linear equations, and then we're going to solve those system of linear equations using matrices. So as step number 1, we will say let X represent the price of adult tickets. Let X represent the price. Let me write that. Price of adult ticket. Price of adult ticket, and then let Y be the price of children's tickets. Let Y represent the price of children's tickets. So as step number 2, and then from the information which is given to us, we can say we can write it out. We can write step number 2 in two different steps. In fact, there are two. The fundraising was held for 2 days. On the first day, this is what has happened. We sold 100 adult tickets. I'll call ticket as T. 100 adult tickets, and then we have sold 175 children's tickets, and then the total amount of money we gathered was equivalent to $1,225. That was the total collection. And on the second day, we sold some more. And on the second day, we saw that we sold 200 adult tickets. We sold 200 adult tickets, and we've sold 316 children's tickets. And then the total collection we've obtained on that second day was equal to $2,348. $2,348. And based on this information, we should be able to write a system of linear equations. And the way to do that is as follows. I'll write that as step number 3. So 100x, because we said let X represent the price of an adult ticket, so we can write this one as 100x plus 175y is equal to 1225. So 100 adult tickets plus 175 children's ticket, the total collection for the first day was $1,225. And then the second equation, on the second day, we sold 200 adult tickets. 200 times x, we can write that as shown here, 200x plus 316. We sold 316 children's tickets, and the total collection we've obtained that day was 2348. So these are the system of linear equations we have, and then we want to be able to solve this system of linear equations using matrices. And we can write this in terms of a augmented matrix, and then we can solve that augmented matrix and then find the value of x and y, and that will give us the value of the adult ticket and the value of a value of one child ticket. So the way to write an augmented matrix from here is as follows. We're going to pick up the coefficient of x and y from equations 1 and 2 and write it in the matrix format. The coefficient of x in the first equation is 100. The coefficient for y in the first equation is 175, and the constant number is 1225. In the second equation, the coefficient of x is 200, and the coefficient of y is 316, and the constant number is 2348. This is our augmented matrix. This is our augmented matrix. Our intention here is to be able to solve this, and then the way we want to solve this is as follows. Our goal is to be able to obtain a matrix, or an augmented matrix of this form: 1a, b, 0, 1, c, and then what we are looking for is we are looking for ones along the diagonal and then zeros below the diagonal. And if once we achieve that, we should be able to find the values of x and y, and therefore we have solved the given problem. So to do that, we're going to to achieve this goal, we're going to use the row operations and then perform that on this particular equation. So in here we want to make this location equal to 1, and the way to do that is as follows. I'm going to write that as step number 6, and then we will go from there. So in equation 1, let me write this. The new R1 is going to be equal to existing R1 divided by 100. Existing R1 divided by 100. And then when we do that, 100 divided by 100, that's going to be equal to 1. 175 divided by 100, that's going to be equal to 1.75. And then 1225 divided by 100 is going to be equal to 12.25. And then we will keep the second equation as is. We'll have this, there is 200 here. Let me write it in black, so that way we know that nothing has changed here. There is a 200 in the second row, there's a 316 here, and there is 2348 in that location there. So this is to write it out in a clean manner. This is what we have: 1.75, then 12.25, and then the second row is 200, 316, and then 2348. So this is the matrix we have, and our intention is to be able to get ones along the diagonal and then zeros in that lower part of the diagonal. So now our intention is to make this location equal to 0, and the way to do that is as follows. We're going to use the row operations to be able to achieve that. Now in here we're going to do this. 1, the first row does not change, 1.75, 12.25, and then the new R2 is going to be equal to 200 times R1, 200 times R1 minus R2, right? So that will do it. So in here, let us see how we can do that. 200 times 1 minus 200, this is equal to 0. 200 times 1.75 minus 316, we'll see what that is going to be. 200 times 1.75 is going to be equal to minus 316. When we simplify that, it is going to be equal to 34, and then the third part here is 200 times 12.25 and then minus 2348, and then when we simplify this part it comes out as equal to 102, and therefore we have successfully completed this row operation. And then to write it in a clean manner, this is how it's going to look: 1.75, 12.25, and then the second row is 0, we have a 34 there, and then we have a 102 there, and then we will put these brackets around this. We'll put this line which is separating the constant numbers, and then we'll go back and then see where we are on the finish line. We want a 0 here, we got that. We want a 1 in this location, and then we will be done with that. So let's do this some more, and then let us perform the row operation some more and then see how we can arrive at that. So to get 1 in that location, we're going to do the row operations as follows: 1, 1.75, 12.25. The new R2 is going to be equal to existing R2 divided by 34, and that will do it. 0 divided by 34, that is equal to 0. 34 divided by 34, that is equal to 1. And then 102 divided by 34, 102 divided by 34, and that is equal to 3. And we have now arrived at the final part of it, and we should be able to solve this augmented matrix and then get the values of x and y, and therefore find the value of the adult ticket and the children ticket. So to write it in a clean format, this is how it is: 1, 1.75, and then this is 12.25, and then the second row is 0, 1, and then this is 3. Therefore this is the matrix we have. And then just to see where we are on the finish line, we wanted the diagonal elements to be equal to 1, and the elements below the diagonal should to be equal to 0, and we have achieved that. And then to be able to solve this system, I'm going to continue this in part 2, and then we will see how we can how to complete this problem, and we will see that in part 2 of this presentation. Part 2 of this presentation. This is part 1, and then if you look for this example 2, part 2, we will see the completion of this particular problem. So see you in part 2 for this completion of this particular example problem.